Today I start Huckel molecular theory applied to benzene, and when we apply that variation principle to benzene molecule, we get these simultaneous homogeneous equation, and in the form of H11 ES11 H12 ES12. I have already explained in earlier videos, and that H is, and this Hij is equal to Fi Fj d Fi H Fj d tau. This is represented as Hij, or if both are same, then Hii. In the similar way, this S is overlap integral, and this is Coulomb integral. Like this I have already explained. So we get this simultaneous homogeneous equation H11 ESS1 for first carbon atom, for second carbon atom, C3 carbon atom, and in this way we get these all equations. Now these simultaneous homogeneous equation can be written in matrix form like this. This is 6 by 6 order matrix, and this is 6 by 1 matrix, column matrix of coefficients, and this multiplication of these two matrix should be equal to 0. By solving matrix algebra and applying Huckel approximation, that Hij is alpha and Sij is equal to 1 if I is equal to j. Hij will be alpha and Sij will be equal to 1. Suppose H11, S22, S33 will be represented as alpha, and S11, S22, S33, S344 is equal to 1. If Hij is beta, if I is equal to not j, but I and j are bonded, then it is beta. If I and j are not bonded, then Hij barabar 0. Example H13, H24, S, these are not bonded. Similarly, Sij is equal to 0 if I is not equal to j, just S12, S13 and S14. When we apply Huckel approximation, then we get this circular determinant. Multiplication of those two 6 by 6 matrix and 6 by 1 column matrix of coefficient must be 0, but matrix of coefficient can't be 0, otherwise it gives the trivial equation. So definitely this 6 by 6 order matrix will be 0. So we can write it in the form of determinant, and this is equal to 0. So we have it is alpha minus E, and when H12 bonded, then beta, and like 0. And for benzene, 1 and 6 carbon atoms are bonded. For benzene 1 and first and 6 carbon atoms are bonded, so it is 1. Keep it in mind that 1 and 6 is equal to 1. So and this is, I have written that alpha minus E, beta 0 0 0, and then 1 2 1 2, that is 1 1 alpha minus E. This will be 1 2, this will be 1 3, this will be 1 4, not bonded, not bonded, not bonded, and 1 6 bonded, so it is beta. Like in the similar way we have written this full determinant, so you can go through. So that determinant which we got, it was alpha minus E beta 0 0 beta. 2 0 0 triple 0 beta, and beta alpha minus E, and beta 0 0 and 0, and 0 0 beta alpha minus E beta, alpha minus E beta, and 0 0, and fourth is 0 0 beta alpha minus E, and beta and 0. Fifth is 0 0 and 0, and third fourth is beta. This is alpha minus E, and this is beta, and this is beta 0 0 and 0 beta and alpha minus E. This determinant we will solve. Now if we divide this determinant by 1 by beta, then what we get? We get that alpha minus E upon beta by beta is 1 0 0 0, and beta is again 1. Now beta by beta is 1 second, alpha minus E 1 2 3 4 5 6, alpha minus E by beta, and 1 and 0 0 0, and now again we get 0, third line 0 and 0, and alpha minus E by beta, third line beta 1 and 0 and 0, fourth line is 0 0 0 0 1, and alpha minus beta, alpha minus E beta. This is 1, this is 1 2 3 4, fourth line. This is 1 and this is 0, fifth line 0 0 0 and 1, and this is alpha minus E upon beta, and this is 1 1 and 1 and 0 0 0 and 1, and alpha minus E by beta. If we write down that alpha minus beta, alpha minus E upon beta is equal to x, then it will be alpha minus E, then it will be x, then we can write this is 0, and if we then we write x 1 0 0 0 1 and 1 x 1 x 1 0 0 0, and third line is 0 0 x and x x 1 0 0 x1 and 0 0 third line में 0 1 x1 third line is 0 1 x1 so how 0 third line 1 2 3 third line is beta by beta therefore it is 1 0 0 x1 0 0 third line 1 2 1 2 and 3 4 is 0 0 1 2 3 1 x1 1 2 3 0 1 x1 0 and 0 and now 0 0 1 x and 1 0 this is fourth line and triple 0 0 0 0 1 and x and 1 and this is 1 0 0 0 1 and x so we get this in the form of x and now we will solve this determinant 0 so I rub this first is x this is multiplicative factor this x and we will ignore this row and this column and we get 5 by 5 order that is x 1 triple 0 x1 triple 0 1 x1 0 0 and 0 1 x1 0 0 0 1 x1 and triple 0 1 x this we get matrix A this is A and this is multiplied by x this is A matrix and second matrix we get second matrix this is x this is -1 plus minus plus and minus so we will get this for -1 this I keep large so I can differentiate -1 ignore this line this column x1 0 0 1 x1 and 0 0 1 we have got x now this is for -1 so we get 1 1 triple 0 1 1 triple 0 and 0 x 1 0 0 0 x 1 0 0 0 1 x 0 x 1 0 0 and 0 1 x 1 0 0 1 x 1 0 0 0 1 x 1 0 0 1 x 1 and this is 1 triple 0 1 x 1 and 1 0 0 1 0 0 1 x, and this is for -1, and third will be -1, again -1, and this I am writing from copy because it is taking much time. 1 x 1 0 0 and 0 1 x 1 0 and 0 0 1 x 1 0 0 1 x 1 0 0 1 x 1 triple 0 1 x triple 0 1 x and 1 0 0 0 1 triple 0 and 1. So this is B determinant and this is C determinant. So we will solve all these T determinants, but here I will solve only this C determinant, and I have already uploaded in detail in my video that solution for determinant. So you can go through solution for of determinant for benzene. This in that video I have uploaded all the three. So now here only I will solve C determinant C. So A minus B and minus C. This is the this will be the form of. So the determinant is like X, A minus B and minus C. So I am taking C determinant, and this is equal to 1 x 1 0 0 0 0 and 0 1 x 1 0 and 0 0 0 0 1 x 1 and triple 0 1 x triple 0 1 x and 1 triple 0 1 1 triple 0 1. So this we take 1. This is first we take 1. This don't confuse with this matrix sign. This is large bracket, and we take in 1, and now ignore this line and ignore this column. So we get 4 by 4 determinant 1 x 1 0 1 x 1 0 0 1 x 1 0 0 1 x and triple 0 1. And let me remove this. When I will need it, I will use. So here again it is in determinant form 1 minus x. This is minus x. Minus x, ignore this column and line. Then 0 x 1 0 0 1 x 1 and 0 0 1 x 0 0 1 x and 1 0 0 1 1 0 0 1. This is minus x, and again plus 1 plus 1 0 1 1 0 0 1 1 0 0 0 x 1 0 0 x 1 and 0 0 1 x 0 0 1 x and 1 1 0 0 1. So first we take this one. Now we use this large bracket, and this one, this is multiplicative factor for this. This is 1x1 0 1 x and 001. Now for this minus x, this 0 x1 0 1 x and 001. And now again for this plus 1 we get matrix 0 1 1 0 1 0 0 x and 001, and this capital. So let me check this. This is 1x1 01x 001 0x1 01x 001 011 00x and 001 minus x, and this is, I take big, stress this minus sign. So again if I get, this is minus x. Now second, this is again minus x. Now this, ignore this row and column, then you get this 0 x1 0 1 x and 101, and this is plus 1 plus 1, so ignore this 0 1 1 0 0 x and 101. Now this second is closed. So here you will get 3 1 2 3, here you will get 2 2, and here you will get again 2. So this is plus 1, and we get this large bracket minus 1 and minus 1. So we get this and this minus 1. So 0 1 0 and 0 x1 and 0, no, this is 0 x1 0 1 x and 101 101, and second is minus plus 1 and plus 1, 0 0 1 0 0 1 0 0 x and 101. 1 1, this is multiplicative factor 1 1, then 1 minus 0 1 minus 0. Now minus x 0 minus 0 0 minus 0 and plus 1 then 0 0 minus 0 0 minus 0. This is now if we come for this minus x and this is multiplicative factor for second, then minus x, 0 minus 0, 0 minus 0, and plus 1, and 0 minus 0, plus 1, 0 minus 0. Now this is for plus 1. Now we take again multiplicative factor, and minus 1, 0 minus 0, and plus 1, 0 minus 0. This is first completed, has been completed. So I put this is for 3, 1, 2, 3. I minus x, 1 and 2, 1 and 2. So here I take this and this. And now I take this minus x, minus x, minus x, and now this minus x, minus x, 0 minus x, 0 minus x, plus 1, and plus 1. So 0 minus 1, plus 1, 0 minus 1. This is for first, and now this is plus 1, minus 1, minus 1, minus 1. This is minus 1. So you get 0 minus x, minus 1, 0 minus x, and plus 1, plus 1. So you get 0 minus 0, 0 minus 0. Now for this plus 1, this is, I will take little big, plus 1 and minus 1. Here I x, yeah, here I will put big bracket, and this is 1, and minus x, and this will be 0 minus x, 0 minus x, and plus 1, and 0 minus 1, plus 1, 0 minus 1. Now it is closed, and plus 1, and multiplicative factor plus 1, and plus minus plus 1, 1, and 0 minus 0, 0 minus 0, and I this. So we take 1 into 1 into 1. Here we get 1 and 0. This is 0, 0, this is 0, this is 0, and this is 0, all 0. This is for first, and this is minus x, minus x, minus x. No, this is minus x, and this is minus x, second minus x, and 0 minus x, 0 plus, no, sorry, minus x, and x minus x, and 0 plus x, y. this is x minus x and 0 plus x square. So here we get x square plus 0 and minus 1. This is closed. This is closed. Now second plus 1 minus 1 0 minus minus plus x plus 1. This is plus 1 minus 0 0 plus x and plus 0 0. This is from this and this is from plus 1, and here I keep this large bracket, plus 1 minus 1 minus 1, and this is minus 0 x square 0 minus 1, this square, and plus this is 0 0 and 0, and this is third is, now I rub this. So from here we get 1 minus x minus x cube minus x minus x cube plus 1, let minus x cube plus 1 plus x, this closed, plus 1, this is minus 1x square and minus x square plus 1 and plus 0. 1 minus x cube plus x, minus 1 minus x minus x cube plus 2x plus, here we will get minus minus plus and x square 1, and here 1 plus x4 minus 2x square minus 2x square. This is plus 1 minus x square, and this is minus minus plus 1 minus x square plus 1, and here, so here I will get plus minus x square plus 1, and here minus 2x square minus x square and plus 1. This 1 and 1 2, and this x4 minus 3x square and plus 2, and this is for C. Now this we keep x, and value of A is x5 minus 4x cube plus 3x minus B is x4 minus 3x square plus 2 and minus x4 minus 3x square plus 2. So we get x6 minus 4x4 plus 3x 2 and minus 4x4 plus 3x square minus x4 plus 3x square minus 2 minus x4 plus 3x square and minus 2. 4x4, x4 and x4. x6 minus 5x4, 4 and 5 and 6 minus 6x4, 3x square plus 9x square and minus 2. So this is the determinant which we have solved, and we get this polynomial equation. So we get polynomial equation x6 minus 6x4 plus 9x square and minus 4 is equal to 0. Now I will solve only one factor for one root, and all the roots I have uploaded in my video, that solution for polynomial equation and energy level. In this video I have uploaded, but here I will take only one. So the factor of minus 4 is minus 2, 2 or minus 1, 4 or 4 minus 1 or 4 and 2, 2 minus 1, 4 and 4 and 1. So we see one by one which factors are the root of this polynomial equation. So suppose we take minus 1, 2. So we will write this equation and with missing powers, just x6 plus 0 x5 minus 6x4 plus 9 x4 plus 0 x cube plus 9 x square plus 0 x minus 4 is equal to 0. And I take, suppose minus 2 I am taking this factor, and suppose in last if 0 is there, this means that this factor is root of this polynomial equation. So we just take this example. Suppose this, I take this 1, suppose 1 is, then write down this equation in 1, 0, minus 6, 0, 9, 0 and minus 4. 1, 2, 3, 4, 5, 6, 7. First this equation will be converted into degree of 5, then 4, 3, 2. And so we take minus 1 or any factor we can take, and this is, say this is, I take 1 or minus 1. So 1 simply get 1, just copy down this one, and minus 1 minus 1, 1 minus 1, and you get here minus 1, minus 1 minus 1 is plus 1. So here you get minus 5, minus 5 minus 5, minus 1 is plus 1, minus 5 and minus 1, here you get plus 5, and here again you get 5, minus 5, 5, and this one minus 5, and here you get 5 and minus 1, it is 4, and 4 minus, it is minus 5, 4 minus this is 4 and 4, minus 4 and minus 4, and here minus 4 minus 1 is plus 4. So you get here 0. Ignore this, ignore, and this is constant. And now this is for x, this is for x square, this is for x cube, and this is for x4, and this is for x5. So in this way we got the polynomial, new polynomial like this. So we are getting here 0, it means minus 1 is root. In the similar way we will try for these all factors, and this is uploaded in solution for polynomial. Next is when we get the solution. Now when we solve this polynomial, then we find that roots are that x बराबर -2, x बराबर this -1 and -1, 2 times these roots are repeating, -1 and -1, and x is equal to +1 and +1, and x is equal to 2. You just solve, or you can see the video. So we see that these are the roots. So now we calculate energy levels. This energy levels again I will calculate for, suppose, -2. So this earlier we know that x is equal to alpha minus eta upon beta. Therefore alpha minus e is equal to beta x. Therefore e is equal to alpha minus beta x. Suppose x बराबर -2, so e1 is equal to alpha minus 2 beta, and is alpha plus 2 beta, and this is energy level 1. And alpha plus 2 beta, alpha is practical experimental value is -1, and this is -1. So negative and plus negative gives you more negative value. So this is the energy level of lowest level, and in this we get alpha plus 2 beta. In the similar way we try for -1 when we get this is E1, and it is represented as bonding molecular orbital, and it is alpha plus 2 beta, and this is E1, bonding molecular orbital having 2 electrons. This is 2, this is E2, and this is E3, and this is alpha plus beta having 2 electrons, and this is also, this is the case of degeneracy, and this is again 2 beta, and this is non-bonding, and this is again alpha minus beta. This is the again case of degeneracy, alpha minus beta. This is empty, and this is E2, E3, E4, E5, and this is E6, and this is alpha minus beta. So in this way we get energy level. All the energy levels I have calculated in my video, you can see. Okay, now when we have calculated energy levels, now we come for molecular orbital. We have got only 3 bonding molecular orbitals and 3 anti-bonding molecular orbital. Here I will calculate only for one, and these were our x1 0 0 0 1, and this is 1 x1 0 0 0, and this is 0 1 x 1 0 0 1 0 0, and 0 0 1 x 1 0 0 0 1 x 1 0, 6 by 6 order की, and 0 0 0 0 0 0 1 x1, and here 1 triple 1 triple 0 1x. This is matrix and multiplied by this C1, C2, C3, C4, C5 and C6, and we get 0. So when we multiply these equations, then we get that C1x plus C2 plus C6 is equal to 0. C2 plus C2x, C1 plus C2x plus C3 is equal to 0. C2 plus C3x plus C4 is equal to 0. C3 plus C4x plus C5 is equal to 0. C4 plus C5x plus C6 is equal to 0, and C1 plus C5 and plus C6 x is equal to 0. These we get these circular equations when we multiply with coefficients, and suppose I take x is equal to -2, and that is phi 2 orbital, phi 1 molecular x1 phi 1, this is for alpha plus 2 beta, and this is bonding molecular orbital. Now this is 1, this is 2, this is 3, this is 4, this is 5, and this is 6. Multiply equation 2 and add equation 1 and 2, 2 and 3 कर दे रहे, 2 and 3, C1, and here I will write down that minus 2C1, here minus 2C2, here minus 2C3, and here minus 2C4, here minus 2C5, and here minus 2C6. When I keep the value of x is equal to -2, we get this. Add equation 2 and 3, then we C1 minus 2C2 plus C3 plus C2 minus 2C3 plus C4 is equal to 0. C1 minus C2 plus C2 minus C2, C3 minus C3 plus C4 is equal to 0. Say this is equation number 7. Now add these 3 and 4. So we add 3 and 4. C2 minus 2C3 plus C4 plus C3 minus 2C4 plus C5 is equal to 0. C2 minus C3 minus C4 plus C5 is equal to 0. Say this is equation number 8. Add 7 and 8. Add 7 and 8. So when we add 7 and 8, then minus C2 minus C3 plus C4 and C2 minus C3 minus C4 plus C5, we get this and this. C1 minus 2C3 plus C5 is equal to 0. Therefore, C1 plus C5 is equal to 2C3. This is, say, equation number 9. Now, keep this value of 9 in equation number 6. Put 2C3 बराबर C1 plus C5 in equation 6. So you get 2C3 is equal to 2,6. Therefore, C3 is equal to C6. You have got one relationship, and keep this C3, C6 into, put value C3 minus 2 C1 plus C2 plus C3 and add. Put C3 बराबर C6 in equation 1 and add with 2 and add with 2. So you get C1 minus 2C2 and plus C3. Subtract and subtract and subtract 2. Subtract 2. C1 minus 2C2 plus C3. Minus, plus and minus. This is 0, this is 0. So you get minus 3C1 plus 3C2 बराबर 0. So here you get C2 is in terms of C1. And now put C2 बराबर C1 in equation 2. Now put C2 बराबर C1 in equation 2. In equation 2. So you get C1 minus 2C1 plus C3 is equal to 0. Therefore, minus C1 is equal to minus C3 implies that C1 is equal to C3 is equal to C6. C1 minus 2 C1 plus C4 is equal to 0. Therefore, minus C1 is equal to minus C4. Therefore, C1 is equal to C4. This is relationship in C4 in terms of C1. Now we keep this value C3. C1 is equal to, put C1 is equal to C4 in equation number C4 in 4. So we get C1 minus 2C1 plus C5 is equal to 0. So minus C1 बराबर minus C5 implies that C1 बराबर C5. So all the variables you have got in terms of C1. So now I can rub this. So naturally C1 बराबर C2 बराबर C3 बराबर C4 बराबर C5 and is equal to C6. So we apply the normalization condition. Apply normalization. Condition. So we get C1 square plus C2 square plus C3 square plus C4 square plus C5 square plus C6 square is equal to 1. So all are C1, so we get 6C1 square is equal to 1. Therefore C1 is equal to 1 by root 6. So we get phi 1 is equal to C1 F1 plus F2 plus F3 plus F4 plus F5 plus F6, because this molecular orbital is linear combination of 6 pi atomic orbitals, and that's it. C1 F1 plus C2 F2 plus C3 F3 plus C4 F4 plus C5 F5 plus C6 F6. So in this way we get that C1 value we got 1 by root 6. This is F1 plus F2 plus F5 plus F6. This is the molecular orbital first, and the other 5 molecular orbitals I have uploaded already in the expressions for wave function. Now next is charge density. I will calculate for the same molecular orbital. So charge can be calculated as QR is equal to summation J and Nj CJR square, because this is contribution of square defines the distribution of charge or contribution of charge to that molecular orbital, and contribution of that rth carbon atom to this J. So suppose phi 1 this 1 by root 6 F1 plus F2 plus F3 plus F4 plus F5 plus F6. This is, and this is phi 2 is equal to 1 by 2 F2 plus F3 minus F5 minus F6. I will write only 3 molecular orbitals because electrons are there only, and bonding orbitals. And phi 3 is equal to 1 by root 3, and this is F1 plus F2 half F2 minus half F3 minus F4 minus half F5 and plus half F6. So suppose I am taking calculation of a charge at carbon atom 1. So this runs over molecular orbital. Suppose I fix molecular orbital is 1. So Nj, this is N1 and CJR square. And this is the square of first atomic orbital to this phi 1, and this is C11 square plus N2, and this is C21 square plus N3, and this is C31 square. Third molecular orbital, first carbon atom. 2 electrons in first C11, 1 by root 6 whole square, and 2 in number of electrons in second orbital 2, C21, that is 1 by 2 whole square plus N3, this is molecular orbital 2, 3, 1, this is first third orbital and first carbon atom. This is 1 by root 3 whole square because it is 1 by root 3. So it is 2 into 1 by 6 plus 2 into 1 by 4 plus 2 into 1 by 3. 2 by 3, this is 2. So 2 by 3 plus 1 by 2. 1 by 2 plus 2 by 3. Let me check. No. Something is wrong. 2 into 1 by 4. And this is F1 is missing. Here it is. F1 is missing. So it is 0. So it will be 0. This first carbon atom, no contribution of first carbon atom to second orbital, so 2 into 0. So it is plus 0. So it is 2 into 2 by, here this is 1 by 3. This is 1 by 3 plus and by 3, 1 by 3. This is 2 by 3. So this you get 3, 1 plus 2, that is 3 by 3. It means that charge on one carbon atom is 1, and you get that Q1 बराबर Q2 बराबर Q3 बराबर Q4 बराबर Q5 is equal to Q6, which represent that the total charge is equally distributed in this on this first carbon atom. That this first carbon charge of first carbon atom is equally distributed, because when we calculate all the charge, then we get Q1 बराबर Q2 बराबर Q3. So this means that whole charge is equally distributed in the benzene ring. So this is for charge. Next is for bond order, and again I will calculate only for one bond order. Bond order is PRS, that is bonding between Rth carbon atom and Hth carbon atom. This is sigma J and Nj, Cj R and Cj S. So I am taking for this I will have to write all the this is 1 by root 6 F1 and F2. Only I will write time 2 because I am taking 1 and 2. And this is phi 1 and this is phi 2. This 1 by 2 F2 plus F3. In this one is missing. Phi 3 is equal to 1 by root 3 F1 plus F2, and this is half F2, and this is phi 4 is equal to 1 by 2 F2 minus F3, and like this, and phi 4 is equal to 1 by root 3. First F1 minus 1 by 2 F2 and phi 1 minus phi 5. This is phi 5. Phi 5 is 1 by root 3, and phi 6 is equal to 1 by root 6 F1 minus F2. F1 minus F2. So this we take P12 p12 summation first molecular orbital nj number of electrons to cjr first carbon atom 1 by root 6 into 1 by root 6 plus now second carbon atom 1 by 2 1 by 2 2 number of electrons 2 and F1 is missing so 0 into this will be 0 and 1 by 2 F2 plus this is for 3 number of electrons is 2 and number of electrons is 2 and this is number of electrons 2 into F1 and F2 this is 1 by root 3 and 1 by 2 into 1 by root 3 so we get 2 by 6 plus 0 plus 2 this is 1 by 3 and 1 by 3 so you get 1 by 3 plus 1 by 3 is equal to 2 by 3 is equal to 0.66 so all you get all the bond order of 0.1 this is 0.66 p12 is equal to p23 is equal to p34 is equal to p45 is equal to p56 is equal to p61 so all the bond order I have calculated in my video bond order charge density and shape of the molecules please if you want in detail so you can go through my videos which I have uploaded in detail for determinant calculation for molecular orbital calculation and for charge density bond order and shape of the molecules so this is all about Huckel molecular orbital theory.